Welcome to the Valve Studio. So I decided it's going to be the Marshall, this JCM800 I got at an estate sale about, I don't know, probably about a month ago. So I got it on the bench here and I downloaded the schematic, and I actually found two schematics. This one here, these are both, Marshall schematics. This is model 2205. This is a 50 watt model with reverb. And I have one that has 2 pages, so I don't know which one I actually have here. So I'm going to need to take it apart, kind of take a look at that, and figure out which one is the legitimate one. This thing here has a problem with the reverb. I'll go ahead and connect that up and show you what that sounds like. It also has a problem where you run for a little while and it just kind of fades away slowly, and then you have to turn it off and let it cool down. So we have a couple of problems to look at. I do want to get this working because it's kind of a shame that I have such a beautiful piece of musical equipment here and I don't even use it. So this is what we're working on. Let's get started. Okay, so I got the cabinet in here. It's a 1960A. It's got 4 12s in it. Got the amp connected up, and I got the foot switch connected here as well. So I'll go ahead and show you what's wrong with it. Basically, all the pots need to get cleaned, that's for sure, because you can hear that kind of crap in it. And right now I'm on the normal channel. It sounds pretty good. But if you play this for about 15 minutes, it's eventually going to kind of fade out. Here's the boost. This foot switch is kind of funky too. Here's the boost. So you can see that it's a lot louder, which is fine. That's all good. And then here's the major problem with it, is when I turn up the reverb gain here. Oops, got the switch off. That's all you get. So we've got to take a look at that amplifier that comes off the reverb tank. We'll go ahead and explain a little bit about how that works. And we'll tear this open and kind of see what's inside this JCM800. And I hope you keep watching. First thing I did was I removed the back cover and I disconnected the reverb tank. But my hands are too big and I couldn't get them in there to get that top one off. Plus I burned myself on those tubes. I was going to take it apart that way, and I figured now it'd be safer to pull it out. Just slide it out. It does weigh about 50 pounds. I went in the other lab and I got out my amplifier rack, and I need to adjust it to be a little bit wider. I have the JCM800 here on the bench. Let's go and take a look. For those of you who have never seen one of these, this is going to be a treat indeed. I know I haven't seen one. I've never even been this close to one of these amplifiers, and to have it on my bench, it's a great feeling. Kind of see that it's got a circuit board here. The potentiometers are all lined up on this front panel, so they're easily cleaned. This is the reverb transformer. This is the driver transformer for the tank. Here are the 2 output tubes. The 2 tubes that are in here, I think they're EL34s, but they're not marked at all. There's a couple of giant caps. It's all very clean. All the wires are actually coated, color coded really well. So what we need to do next is to do a schematic review, kind of do some estimations for voltages, and then we'll come in and try to figure out what's going on. Here's the top view before we start taking it apart. You can see that the output tubes have retainer clips on them, and all the Well, the preamp tubes are shielded. These are Drake transformers back here. That's the choke. And I believe that this is the output transformer here. And this is the power transformer. It's a monster. It's just a monster. This thing weighs about 50 pounds without the enclosure. A couple months ago when I was in Denver, I stopped by Vacuum Tube Supplies and I talked to them for about a half an hour and I got a copy of their work order. So this is the kind of thing that they actually do if you brought an amplifier into them. There's a failure description here. Well, this is all your contact information up here. Failure description, this is all your intake here. This is the tube section where they actually measure. They take every tube out and measure it, make sure that's all functional before they get started. They write down the G sub N values as well. And then here's their checkout procedure, all the things that they did on the way back out. And the one I find most interesting is they do high pot testing up to 1,000 volts. I don't know if I'll do that. I do have the capability of doing that here, but I don't know if I'm going to do that today. So I'm going to try to follow along as best I can for this. I don't need to fill in the failure description. This is my amplifier. Don't need to do that. So I have my Hickok 605A tube tester here. I got out the operating instructions that someone photocopied a long time ago, and I looked through here, and there's a little problem, of course, in the section. This is the foreign tube data, because a lot of these tubes up here are ECC83s. So this is a supplemental manual, and when somebody copied this, they lopped off this section of the page. So ECC 80, like 2, 3, up to the next page is ECF 82. You can kind of see that this is where their page was when they're running it through the copier. So what is the ECC 83? Probably the second most popular tube in the world. We don't have the data for that. All right, so it's not a problem. Fortunately, I found this. This is the consolidated test data for my tube tester. And this isn't a scan. This is actually somebody came in and kind of retyped all this information. I don't know who has that time, but I'm awfully thankful. So we have our section here. And these settings are actually going to be the same for ECC 83 and 81. All that's really different is the G sub M, the mutual conductance. So I have taken out one of the tubes in this my JCM800, and I ran it through here. And what I'm doing now is I'm testing the second triode on all these other tubes. So I have this one in. It's pretty warm. I'm going to check the conductance here. And you can kind of see that we're over in the good range. In fact, we're up pretty high up in the good range. Don't charge the meter face. That's one thing we don't want to do. So that one looks pretty good. We're sitting at probably around 5,500. So what I want to do is actually measure the other triode on this. So right now we are on settings 7608, and we need to move to 2103. And we test it again. And what we're looking for here is that the tubes kind of roughly match on both sides. Although it's not that important on this amplifier, there's not a place where the phase inverter in this doesn't use long tail pair, so it's not really that critical that both sides match. Most of them are really treated as single amplifiers. So this one's looking good, so we're going to do another one. And what I don't have in here is like a pot holder. It's kind of strange. I don't even have a rag or anything. I guess my fingertips are going to need to get used to picking out hot tubes. So we'll do another one here. And there's some flashing going on down here when these things power up. I'm actually going to have to do a little research into why that happens. So I'm on one triode here at the 2103 setting. We come up and we're way over up here. So, the other thing I didn't do is I could test for shorts. So on this tube tester, I can test for shorts. You basically run through all these things here, and if a short exists, this neon tube will light up. These little flashes here are not an indication of a short. A short would be kind of a glow. All right, so we're way over on that. I have to look into why that is. The other setting is 7608. And we'll see if this one matches as well. Not so well here. But like I said, it doesn't really matter that much. So what I'm going to do is write that down. That I am on number 3, V3. Lost my pen in my mess of crap here. All right, well, I'm going to continue on testing this out, and I'll be back here in a little bit. Okay, it's time for the power tubes. This is what was in there when I got it. There's absolutely no markings on this at all. So the schematic over here says that these are EL34s, but in the United States they're 6550s. I don't know what I think this is an EL34, but it's probably a clone. There's nothing on this at all. It looks like there might have been an indication up here. This amplifier might be probably 20, 30 years old, so I don't know what these are. I've got this set up for EL34s, so we don't really know kind of what we're doing yet. But what we can do is actually check and see if our G sub M is close on both the tubes. All right. So I got this set up. We are on 6.3 for our filament voltage, and our settings are J, R, 5347-2. This is for the suppressor. And we should have our bias set to 23, which it is, and the English set at 90. So we click this on. This thing draws a lot of current here because this thing is, the fuse lit up a lot when you turn it on. So the inrush current in this tube is quite high. When that happens, you want to check the line voltage over here. So there's a line, and we want to dial up the line pod over here, which is this is a rheostat hooked onto the transformer. When the current in the filament's so high, you're going to bring down the voltages everywhere. So you want to adjust this when you first put this in. Then we'll test the tube test. We come through, we're testing for shorts. We're looking pretty good there. It's warming up. You may not be able to see it. I think you can. There's a little bit of a glow here. And we are down, way down. This is roughly about 2250. And this is pretty stable, so our tube is warmed up. So let's try the other one. I just put some socket savers in this thing, and I think that this might have been the first tube I put in here. That's a octal. It's an octal tube. All right, here's tube number 7. So we'll let it warm up. Do our line test again. So our line test looks good. Tube is warming up. This one takes a long time for it to go, but here you can watch it kind of run up here. It's pretty slow. This amplifier does take about 30 seconds to warm up. Still kind of creeping up there, but we're roughly 1950. It's kind of stopped 1950. Okay, so what we have here is two output tubes in a push-pull configuration that are suspect. They're also not very balanced. We'd have to fix that in the biasing to get our the Q point, the quiescent current, to be equal. It may or may not be possible. So what I'm going to do is have some friends here in town. I'm going to see if I can borrow some EL34s from them, get this amplifier running. What's amazing to me is how loud it is right now with the tubes that are aged. For me, this thing is wildly loud. But let's get this thing tuned up and get it back on the road. Well, I've made a little progress this evening. First thing is, here was my old manual that had that ECC83 kind of cut off of it, and I did find another a better version of that. But it turns out when I opened up my PDF document, I think that this is the scan of the same document, but this one actually printed out right. So I might have been the idiot that actually printed this out. So I'm going to throw that away. So I have the complete manual here. I did call up a friend of mine here in town. His name's Jerry. And I said, hey, do you got any EL34s I can borrow? He said, yeah, I got a quad down there. I can let you have a couple. I'm just going to borrow them, kind of get this thing working. I took my mystery tubes over to his place, and he put them on his Hickok 800, and he measured the GSM around 5500. And we noticed something over there that's a little bit kind of peculiar. He told me about the life testing, which is where you click the filament voltage down by one click. So these are running at 6.3. If you click it down to 5, you actually want to look at where the G sub M moves. And if it moves more than 10%, that tube is kind of near its end of life. So we were fooling around with that. And one of these tubes just kind of kept one of these tubes just kind of kept falling and falling and falling and falling, and eventually fell to 0, which is about the rate at which, when the amplifier dies, what happens. So he marked that tube as bad, and what I wanted to do was come over here and show you that on my tube tester. I can't get the same kind of results on this, and in fact, I think that this tube tester that I have here needs to go through a calibration run, because I did check out a bunch of stuff. There's a calibration procedure here, and I went through that, and I can't get it to be calibrated at all. And yeah, like the readings in the calibration procedure are for a voltmeter that's got either 20 k ohms per volt or 1 k ohms per volt. So I don't have that, in here I only got these 10 mega ohm things. So I dug out this Simpson meter to give me 20 k load. And it turns out that this Simpson meter, can you see that? Yeah, this Simpson meter here actually matches up pretty well with my digital HP digital multimeter. Where does that leave us? I'm going to have to cut it off tonight. It's getting kind of late here. We can still show you a few things here. It's just the G sub M measurement will be flawed relative to picking tubes to find out if one is kind of matched to another. It's okay for that, but if I wanted to know the absolute value for G sub M, I can't do it with this tube tester until I figure that out. So I think I need to do that, but I'm going to cut it off here. We do have some extra EL34s that we can play with, and I will fool around with this, and then once I get it all straightened out in my head, I will get back on fixing this JCM800. All right, this is the Valve Studio. Thanks for watching.